name is Bryce.
I'm Chris. We're from the Robotics team, FRC 2357 System Meltdown here in Missouri. We have an Omio X8 router that we've had a couple issues with in the past, and we're looking at upgrading to a MASSO controller. Some of these problems include we've had an axis stopping the X and the Y while we're trying to cut. We've had reliability issues, accuracy within the stepper motors, and we're looking for closed loop control and no PC, more I/O slots. These are a couple of benefits that the MASSO offers. In this, we reached out to MASSO, we're partnering with them, and Bryce will talk us through
what we're doing is we're replacing the controller with a MASSO controller as well as the motor and new limit switches. So what we've done so far is taken off all the motors and the limit switches and taken all the wiring out. And we've started assembling the other controller to put on this router.
So now we're gonna work on wiring up the motors. So we've got the wire that came with the kit, the control cable, the power cable. We started just by stripping the outside, cutting out the shielding, and then there's no shielding on this one. And we'll just go strip each wire one by one and go to the screw terminals here and wiring it up according to the wiring diagram.
We have a receptacle going to the switch which feeds 120 volts into a line of terminal blocks, which brings power to these power supplies, which then puts 24 and 36 volts back into these terminal blocks, which feed things like our motors, our fans, and anything else that needs power. We added 4 extra outputs into this cabinet for planned upgrades like dust collection and air.
All right, so here we have the 2 cables provided by MASSO that we're running to our motors and then back to our control box down below. We also, one thing good to mention is we upgraded our energy chain here.
We mounted our MASSO limit switches here, and we made custom 3D prints that move with the tool to trigger the limit switches. So from the terminal blocks, each of the motors got an Ethernet cord up to here, which controlled our step, direction, and home. And we labeled each of them before we ran them with different colors of electrical tape. That was pretty helpful. And then as far as for the homing switches, we junctioned the power and ground of those together with Wagos and ran them to the power and ground of the controller, and then we also ran them to the inputs.
So here we have our VFD. It's the same one that we pulled off the old router. We didn't upgrade the VFD for this at all. This Ethernet cord runs all the way back up to our MASSO control screen, and we followed some documentation that we found on the MASSO forums for wiring this with all our inputs and outputs right there. These cables down at the bottom here are what goes from the VFD all the way to the spindle. We've got it wrapped in that ferrite core that came off of it to eliminate the EMF. Also in this shot here, we've got our fans. We've got 2 on the other side, 2 on this side. 2 of them are pulling, 2 of them are pushing, so we get some really nice airflow to the case. Okay, these Ethernet cords bring in the inputs and outputs from our control box down below, like our motors, our tool sensor, and the rest of it. Each of it goes to the corresponding spot on our board here. MASSO also sells a breakout board that would take all of this and move it back to the control box. We would much rather do that next time. However, this time we just didn't do it, didn't think about it. For all this is just unshielded Ethernet cord. It works fine, carries 6 cords, pretty solid.
After wiring it, we turned it on and installed the MASSO software. Once we got there, we came over to the setup page and started going through the inputs and outputs one by one, assigning the different inputs to each thing. And then we set our motor travel soft limits, as well as our lead screw. It had a pitch of 5 millimeters, so that came default on there, and that's standard for a lot of machines. We also noticed that the motor pulse resolution affected your max speed that you can go. So a higher resolution, you'll have more accuracy, but you won't have as high of a top speed. So we did 5,000 for our X and Y axes, but 20,000 for our Z axis, since we didn't need as much speed there. And then we also hooked up our tool setter so that it could automatically set the length of new tools put in. And you can see that here, whenever I press that down, that bottom input changes.
Overall, we've been really happy with the MASSO build. It's just, we wired up, we go and we install the software, and all of the settings were really easy to use. The control was really easy to use. It's very intuitive. There's a lot of documentation out there, a lot of videos other people have made that truly explain every part that we're looking for in the error codes that we went through. Didn't really have too many, but if we were to have them, there's some great explanations out there and a lot of help in that department. The motors and homing switches that we got from MASSO have been very accurate. They're very consistent. They are exactly what we were looking for, and we're glad we chose them. We've enjoyed getting to use the tool setter. We could do it on the old one, but just the ease of use and consistency that came with the MASSO, we finally got one, and we're very happy with that as well. Another thing, the MASSO is really good for adding I/O. We'll probably add solenoids in the future for air, to clean up the tool setter, for the blowgun, anything in general. It's very simple to add, to just drop in more stuff if we chose to for an ATC or another axis. Or, just in general, it's been a great build. We're very happy with what we've done, and we're very thankful for MASSO for empowering us to do this.